Okay, hi everyone. Today Lorenzo will speak to us. Lorenzo Innocenti studied environmental engineering at the University of Florence, and then he pursued a PhD, moving between Florence and the Technical University of Braunschweig. Currently, he is doing a postdoc at the University of Florence, carrying out different researches related to rivers, ranging from geomorphology to wood transport and the dynamics of microplastics in river ecosystems. So, Lorenzo, the floor is yours.
Thank you, Melissa. I'm going to share my screen and my presentation. Okay, so I think you can see the presentation.
Yes.
Okay, so thank you for the presentation. Thank you everyone for being here. So this is the theme I choose for the presentation of today. So when Melissa and the staff of the Young Professional asked me for making this presentation, I found interesting to present this part that comes partly from my research for the PhD and that I finished a couple of years ago, and partly from a more recent project that comes and is promoted by the Italian Society of Hydraulics. It is about the processes and the problems related to wood obstruction at bridges. So in order to introduce you into this topic that probably is new for many of you, the really first key information that you need to keep in mind is that when we are talking about wood, and in particular large wood, as we are commonly calling it in the literature, we are only referring to the wood elements that has a diameter greater than 10 centimeters, sorry, and with a length greater than 1 meter. In this case, we can, as reported in the sketch on the top left of the slide, we can consider or not the presence of roots or branches. So why it's important to consider the presence of these elements while considering all the processes that we have in our rivers? First of all, we have to consider that the composition of wood is the really first process that provides nutrients for the river ecosystems, and so it's really important for the river habitat and the restoration. But it's also important while considering the flood propagation, so the flood wave propagation, as the transport of these elements are mainly during floods. We have to consider that a large amount of wood could be mobilized during huge floods, and this may create hazards for people and infrastructures. And also the third reason is also because these elements, the presence of wood accumulation could usually induce a change in the river morphology. In particular, this presentation is focusing on the occlusion of bridges, so due to the presence of wood accumulation. So again, to introduce, we have the presence of wood that is good for in the ecological point of view, but when the wood is transported, it may be trapped at the bridge piers, for example, as in the sketch at the bottom of the slide. Once we have this accumulation, which are the results? First of all, we have a backwater effect that induce higher water levels in the upstream part of the river, and also the accumulation of wood at the bridge piers increase the bridge piers cover at the bottom of the river. So for these reasons, we have to consider the presence of these elements of large wood in our simulation and our projects. Which are the type of accumulation? We can define two different main accumulation types. The first one is called usually single pier accumulation. In this case, we have that these elements accumulate at at a single pier of the bridge, of course. In this case, we have a particular shape of this accumulation that evolves along the height of the bridge piers. On the opposite, we can have the span blockage accumulation. In this second case, we have not that the accumulation interact only with one pier, but interacts with more than one pier. And as reported in the picture, we have in this case the creation of a sort of a carpet that is not evolving in the elevation, along the elevation of the bridge pier, but on the plan. In both of these two kind of accumulation, we can recognize the so-called key member, that is the pieces that starts the accumulation, and the racket members that are the majority, that are all the elements that comes later and stopped due to the fact that there are already some elements that are entrapped by the bridge piers. Which are the factors that are that has influence on the river accumulation? That are a lot of factors. First of all, we have the bridge geometry, of course, so the presence of piers is fundamental, but also the shape of the piers and of the deck of the bridge. So there are some examples here in the slide. The approaching wood flux, so the quantity and the shape of these large wood elements. So, and in particular, the large wood transport regime. In this case, we can have maybe few elements that are transported downstream without interacting to each other. So for these elements, it's lower the probability to be trapped at the structure, while on the opposite, if we are in a sort of congested transport regime, so there are a lot of elements that are moving as a unique mass. In this case, it's more probably that these elements will stop at the bridge piers. And finally, also, we have the approaching flow conditions, so the flow discharge, flow velocity, and flow regime. So, due to the fact that these elements are mainly transported during flood events, and so in such a condition in which it's really difficult to perform field observation or field measurements, most of the formulas that could be used and for defining the shape of this accumulation comes from the experimental laboratory analysis. So in this case, I reported the example of the physical model of single pier accumulation, for which the classical shape for the accumulation is a half cone. In this case, characterized by 3 main dimensions. For this, by experimental analysis, we know today some information regarding the characteristics of this particular shape by varying the approaching flow condition. So by varying the flow condition and defining the length of the key member that starts the large wood accumulation, we can have an idea of the final shape of the accumulation itself, and also about the probability. We can find in the literature some formulas that define the probability of accumulation at the bridge piers and or bridge decks, due to the fact that we need to know the information about the flow regime, the information about the trees that are living in the area along which the streams flows, and so on. This is only an example that comes from the paper by Schalko et al. 2019. So I choose this topic also because it's important, of course, from the research point of view, but also it's important because from sorry, the practitioners, because when an engineer usually needs to design a bridge, he will usually look into the national legislation or reports in order to define which is the better shape for its structure. But in these legislations or reports, rarely there are something that about the transport of large wood. So in these cases, there are a lot of questions that remain without answers for the practitioners. And due to this fact, we start to work on this topic with the project that I mentioned while starting my presentation, and for which we started to review the existing methodologies. In particular, we reviewed the existing methodologies for these 4 countries that you can see here on the right. So for the US, the Switzerland, UK, and Italy, in order to find which are the main differences between the regulations between different countries, and to see if, in our case for Italy, how to provide better information for practitioners. So starting from the US, we have here some guidelines that are provided by the Geological Survey and Federal Highway Administration. In this case, they define a 3-phase analysis. The first one is about the definition of the potential for the stream to deliver wood. So first question is possible that to this structure we will have some large wood elements? So we have a low or high potential. Then we can move to the estimation of the drift potential, and in this case by considering the large wood length that comes from surveys in the woods. And the final 3rd phase is the calculation of the hypothetical accumulation for the entire structure. That comes from the phase number 2. In Italy, for Italy, we have something about large wood in the hydroin methodology. That is a methodology developed by Rinaldi et al. In 2014 and 15. That allow to the definition, the estimation of the again, the occlusion of bridges by considering only qualitative characteristics. So the bridge geometry, the presence or not in the past of accumulation, and so on. And also in this case, as for the US, we have the definition of a low susceptibility or high susceptibility. And then the second phase is the evaluation of the clocking probability that is made by only following a flow chart. So no calculation in this case. What is interesting or strange is that in the technical standards that there is the requirement for the designer to consider the probability of the wood accumulation, but there are not guidelines or procedure that are provided to achieve this task. For Swiss, there is something new with respect to what we observed for US and Italy, and this is that in the Swiss legislation, we can find the definition of the freeboard that need to be considered in the case of transport of large wood. In this case, so the legislation provide a formula to determine which is the freeboard that could be considered by the designer in the case of large wood transport. This value comes from the table that is at the bottom of the slide, and is a function of the characteristics of the large wood elements and also of the characteristics of the bridge. Finally, for the UK, this is the most recent legislation uploaded a few years ago in 2020 by the management by the national highway for United Kingdom. In this case, they provided a semi-quantitative estimation of the large wood accumulation, and on the basis of this evaluation, they provide the procedure for the estimation of the risk and the vulnerability for scour, in particular for scour. So for the problem of scouring at the bottom of the pier, while nothing is reported about the backwater effect. So in order to compare these four cases that we consider, in order to make to highlight the differences, only in the UK there is the inclusion in the national regulation of something about the large wood accumulation at bridges. Also, in all the cases, we have only qualitative estimation, while with the only exception for UK that provide also a semi-quantitative estimation, only for the case of single pier bridges. So the accumulation shape is usually the accumulation at a single pier, and so while with considering the half cone shape, as I reported in the previous slides. And what is really important is that the wood accumulation impact is not considered in the US legislation, and only partly considered in the Swiss and Italy legislation, with the thing that I showed before, while for the UK we have a quantitative evaluation of the scour and the backwater, qualitative evaluation for bridge potential failure. So in order to conclude, there are already existing or planned regulation or guidelines to lead the estimation of the potential accumulation at bridges, but mainly of them are only qualitative. Only for the UK regulation, we have the impact of the wood obstruction is analyzed quantitatively, although limited to the accumulation at a single pier bridge. So without considering the span blockage accumulation method. Here there is I don't know, a scheme, a table that reports the remaining challenges for all the processes connected with the presence of large wood in rivers. This table comes from a few years ago, from 2018, from the work of De Cicco et al. But these tasks remain open, so it's something that, on which we have to work and to consider while designing a structure as a bridge. So with this slide, I thank you for your attention. Here there is the website for the project that I mentioned before. And really last slide is to remember the next coffee break presented by Cosimo Peruzzi that will be held on the 16th of May at 2 p.m.
Thank you very much, Lorenzo. And we have some minutes for any questions you might have. So if you have a question, just ask Lorenzo.
Yes, I may ask a question. If you are also planning to investigate this phenomenon also in dams, and we are in rivers, not only in bridges.
Yes, there are few studies that are ongoing about that, and in particular after really recent events that consider a large amount of wood that was transported into a lake by the presence of a dam, and these are mainly for the design of the spillway of the dam in order to avoid the occlusion of these elements in the case of high flood. Yeah, and I'm not really working right now on on this phenomenon, on the study of this phenomenon, but there are some colleagues, in particular from the Swiss part. For example, Isabella Schalko that I mentioned before from the IATH of Zurich, that is working with her team on this topic. Yeah.
Thank you.
And I have a question. First of all, thank you. I found this presentation very interesting. I knew nothing about this topic, about the regulations in the various countries, so thank you. And in the last slide, you mentioned that there is still a lot to do about modeling, about numerical modeling in particular. And so I was wondering if there are researches in this sense that try to find an easy way to model wood transport in order to support policy, for instance, and if the models can simulate the two different kind of accumulation that you mentioned.
Okay. Yes, there are already few studies about the numerical modeling of the transport of large wood. In particular, there are also some free software that have inside a module to simulate the transport of these elements. In most of the cases, these are models that are coupled with an hydraulic models, and in particular with the 2D depth average models. And the main example is the model Hiberwood that is was developed by Ruiz Villanueva, and with yes, in an old project that comes from 2014, if I remember, and that is based on the 2D depth average model Hiber, that is an hydraulic model developed by the Polytechnic University of Barcelona. So this is the main, but there are few. Also, we have also in Italy some example, something also here in Florence, but really not open because of the state of the model. But yes, there are. This is an open topic. It's really, there are a lot of people that are working on, and also the numerical simulation is really considered a lot to provide simulation and to forecast what happened during flood in the case of huge presence of large wood.
Okay, thank you. Are there other questions?
Hi, I have a question. Hi, Lorenzo.
Ciao.
A very nice presentation, and I was wondering if I want to improve the transport of goods in a river, no, that have a bridge, for example. The best action to the bridge, what they are the best action to reduce the risk of flooding induced by large wood accumulation. Of course, I think to eliminate the piers, but in the case of you cannot do that, maybe the shape, I don't know. So I ask to you.
Yeah, it depends. As you said, it depends really on what kind of structure we are considering. In the worst case, as for example, we cannot directly act on the bridge shape, bridge geometry. We may consider the possibility to build something upstream to catch these elements, and for example, or something as I don't know, a veil with a particular shape to collect these elements, or what is better is to allow the elements to be transported in a lateral channel, for example, where we can, and with this second option, we remove completely the presence of large wood from the main active channel of the river. So we move all the the wood elements to an area that we are sure they are not dangerous. And we can do that by, of course, building a proper design channel for doing that. There are already a few examples, in particular on the Alps from the Switzerland. There are a couple of examples that I have in mind on which they design, test, and then realized these bypass channel that are really sort of a channel for collecting large wood elements.
Thank you. Thank you very much.
You are welcome.
Okay.
Yeah, we have 2 minutes left until the meeting will close. So if we have a quick question now, or we can just finish the coffee break.
Okay, I think we have no questions left. So thank you again, Lorenzo, for your presentation. And thank you for everyone for participating in this coffee break, and see you at the following coffee break, where will be on 16th of May. So thank you.
Thank you.
Bye.
Thank you. Bye bye.
Bye bye. Ciao ciao a tutti.
Ciao.
Bye.
Ciao.